we prepared for. Okay, so objectives, um, introduction, we did. That's the lesson overview. Definition of some technical terms and the types of events we did. Sample space for some experiment we did. Definition of probability, loss of probability, and relative frequency. We also tackled combination of addition and multiplication laws of probability. This is where we got to the last time. And today we shall end it all with selection in probability with or without replacement. Let's see how we can apply that even in our daily lives. So we've been able to determine the sample space of a simple and compound experiment. We can also calculate the probability of an event, and we can also interpret or in probability as addition and in probability as multiplication. So we are just going to take the last aspect of probability, selection with or without replacement. The last time we solved questions on the addition and multiplication laws, I want us to go through the second example there again. And the second example there, we have this question. In a contest, Abina, Kwame, and Ernest were all asked to solve a particular problem. And their probabilities that they were able to solve the problem are 1 over 2, 2 on 3, and then 5 on 6. You were asked to calculate the probability that none of them solved the problem, at least one of them solved the problem, only one of them solved the problem. So we looked at our suggested solution. You were given the probability that Abina solved the problem to be 1 on 2, probability that Abina did not solve the problem will be 1 minus the probability that Abina solved, which is the 1 on 2, and the answer is still 1 on 2. Probability that Kwame solved the problem was given as 2 on 3. So probability that Kwame did not solve the problem will be equal to 1 minus 2 over 3, which is the 2 over 3 there is the probability that Kwame solved the problem. So the probability that Kwame did not solve will be 1 over 3. Again, the probability that Ernest solved the problem was given as 5 on 6. So probability that Ernest did not solve the problem will be 1 minus 5 on 6. That gives us 1 over 6. Knowing their respective probabilities of solving and the probabilities of not solving the problem, we can now solve the first part. Probability that none of them solved the problem will be equal to probability that Abina will not solve the problem and Kwame will also not solve the problem and Ernest will also not solve the problem. So we have the probability that Abina will not solve the problem to be 1 over 2 times the probability that Kwame will not solve the problem to be 1 over 3 times the probability that Ernest will also not solve the problem to be 1 over 6. If you solve the expression there, we have 1 over 36. So 1 over 36 is the probability that none of them solve the problem. We want to find the probability that at least one of them solved the problem. And we said to find the probability that at least one of them solved the problem is equal to 1 minus the probability that none of them solved the problem. And we know the probability that none of them solved the problem. We calculated that in the A above. So we do the substitution into this formula here. This will give us 1 minus 1 over 36. 1 over 36 was the answer obtained in the solution above, which is the probability that none of them solved the problem. So we have 1 minus 1 over 36, and that will give us 35 on 36. So this is how to find the probability that at least one of them solved the problem. The last one, which is the third question there, we are to find the probability that only one of them solved the problem. So if only one of them is solving the problem, what it means is the other two will not solve. Who will not solve the problem? And which of them will solve the problem? We don't know. So we need to write expressions connecting the possibilities of all of them solving, and at the same time, they will not solve the problem. So this is going to give us the expression first, probability that Abina will solve. If Abina solve, it means Kwame and Ernest will not solve. Or the probability that, so the plus there is the same as or, the probability that Abina will also not solve. In this case, Kwame will solve. If Kwame should solve, then Ernest will also not solve. So at least we have one person here solving. And again, we also have the probability that Abina will not solve and Kwame will also not solve. This time around, Ernest is going to solve the problem. Now, if we do our substitutions correctly, we have 1 over 2, which is the probability that Abina will solve, times 1 over 3, the probability that Kwame will not solve the problem, times 1 over 6, which is the probability that Ernest will not solve. The whole of this expression plus another expression, 1 over 2, which is the probability that Abina will not solve, times 2 over 3, which is probability that Ernest will solve, times 1 on 6, the probability that Ernest will not solve, plus the last expression, probability that Abina will not solve will be 1 on 2 times probability that Kwame will not solve 1 over 3 times the probability that Ernest will solve the problem 5 over 6. So if you simplify each of the expressions there, the whole of the first expression will give you 1 on 36 plus the whole of the second expression will give you 2 on 36 plus the whole of the third expression will also give you 5 on 36. Putting all the three expressions together, it gives us 8 on 36, simplified to 2 over 9. So 2 over 9 is the probability that only one of them solved the problem. Tiola, is that clear?
Yes, sir.
Good. Emmanuel Kumado, is that clear to you?
Yes, sir.
Good. Now, if no question, then we move to our lesson for today, probability 4. Selection with replacement, that is for independent event. Selection with replacement. Now, In our daily lives, you will see especially our mothers who sells in the market. If you go to the tomatoes sellers, you will see that they will gather the tomatoes on a tray. If you go to buy one, if you pick one or you collect one, immediately they will replace it. So sometimes you go to the market and you will see some of the tomato sellers. If you look at their faces, as if nobody is buying from them. People buy, but they don't want people to know. The moment somebody comes in to buy, they will pick from another basket and fill that particular space. They were practicing probability, that is selection with replacement. How do we apply this? If you have a certain number of items and you pick one, if you pick one, something will happen. For example, you have 6 mangoes in a basket. If you pick one mango out of the 6, the total number of mangoes will reduce. But if you replace that same mango again, the total number of mangoes will still be the same as the original number. That is replacement. So at any point in time, if you should replace, the total number of items which were in the basket before you selected will still remain the same before you make another selection. Let us pick a typical example and see how we can apply this probability involving selection with replacement. The first example. A box contains 7 white balls, 5 black balls, and 8 red balls of the same size. So let's assume that we have a tennis balls of different colors. That's 3 different colors: white, black, and red. They are all of the same size so that in the process of selection, you will not be biased. A ball is selected at random from the box and then replaced. A second ball is then selected. Find the probability of obtaining A, 2 red balls, B, 2 white balls or 2 black balls, C, 1 black ball and 1 red ball in any other. This is the question to the class. Let's see how we can solve this question. So please quickly copy this and let's move on to the solution. Solomon Asante, have you finished?
No, sir.
Okay. Amenu Diana, have you finished?
No, please.
Okay. Tameklo Shelga, have you finished? Senanu Kelvin, have you finished?
No, please.
Okay. Danso Peace.
Yes, sir.
Okay. Miriam, have you finished?
No, sir.
All right, now let's go to the solution. Solution. First, you were given the number of white balls to be 7. So we are using their first letters to represent the type of colored balls that we have. Number of B, which is the number of black balls, equal to 5. And the number of red balls, which the R here represent the number of red balls, equal to 8. So the sample space, the number of U will be equal to 7 plus 5 plus 8. That gives you 20. So it means that in all, we have 20 balls in the basket, out of which we are going to effect our or make our selection. We are to find the probability that the first two balls are red. So if the first two balls are red, then we will have probability of having two red balls will be equal to the probability that the first ball is red. So 1R there means the first ball is red. And the second ball is also red. That's the 2R. Probability that the first ball is red is represented by 1R. And the probability that the second ball is also red will be represented by 2R. Now, the intersection we all know is multiplication. So this will now be equal to, we know the probability of picking a red ball, and that will give us 8 over 20. The 8 there is the number of red balls. So if you pick one red ball, the probability of picking one red ball will be equal to 8 over 20. Now, if you remove one red ball, the number of red balls will reduce to 7. But remember, we are going to replace it. So if you are going to replace it, it means that you have extra red balls in another basket. So you pick another ball from another basket and put it into the basket in which you are selecting from. So the total number of red balls will still remain 8 before you effect the second selection. So now, times the probability that the second ball is also red. So now, since we still have 8 red balls, the probability of picking a second ball, which is red, will also be 8 over 20. Now, if you simplify the expression there, that will give us 2 over 5 times 2 over 5. And 2 over 5 times 2 over 5 is going to give us 4 over 25. And that is the probability of picking two balls. Akitipel, are you following the solution?
Yes.
Good. Emmanuel Fumado, are you following the solution?
Yes, sir.
Good. Danso Peace, are you with us?
Yes, sir.
Great. Copy this quickly. Then we move to the second part. I will be asking you how we will tackle the second part. Francisca Sando, can you tell us how we will tackle the second part? Francisca Sando, are you there? Amuzu Matthew, how do you do the second one?
Sir, please the second That's the B.
Yes.
We will find for the first probability, that's 2, all close, plus probability into bracket, uh, B1, that's the blackboard intersection, blackboard, that's the 2. Then after that, you intersect the numbers inside. That's 7/20 times 7/20 plus 5/20 times 5/20. You get 49/400 plus 1/60. After adding, you get 37/200.
All right. I think that's a good explanation. But let's see if someone is also having another way of giving us a similar solution. Send Nanu Kelvin. Send Nanu, we are waiting for you. Shelga. Shelga. Can you explain the second one? Okay, let's look at the suggested solution to see whether it is the same as what our brother gave us. Probability of having 2 white balls or 2 black balls. So we said the or there means addition. If you are going to have 2 white balls, then you have the chance to select the first white ball and the second white ball. Or you select the first black ball and the second black ball. This is equal to probability that the first ball selected is white and the probability or yes, that the second ball selected is also white. Or the probability that the first ball selected is black and the second ball selected is also black. Which are the probabilities? Probability that the first ball selected is white will be 7/20, and you know that the number of white balls will reduce by 6, but we are going to replace it from another basket before we do the second selection. So the probability that the second ball is also white will be another 7/20. Again, we can say that the probability that the first ball is black will also give us 5/20 times the probability that the second ball is also black will give us 5/20. So the first expression here, if you do everything there, you will get 49/400. That is the 7/20 times 7/20 will give you 49/400 plus 5 times 5 will be 25 divided by 400. That is 20 times 20. Now, the times here is supposed to be plus. Let me use annotations here for you. This is supposed to be plus, so you take note of that. This is plus. Good. So if you add the two fractions here, is going to give us 74/400. And you know, we can simplify this answer to obtain 37/200. So this is the probability of selecting 2 white balls or 2 black balls. Danso piece. Is that clear to you?
Yes, sir.
Of patience, are you okay?
Yes, sir.
Good. Copy that quickly and let's go. If you have any question, you can raise your hand and then ask your question. before we move on to the next thing. Apedo Roots, have you finished?
Yes, sir.
I'm a macho courage. Nukunu Frank, have you finished?
Yes,
Okay.
sir.
Amadi Prosperity, Deborah Paula, are you guys listening at all?
Yes, sir, we are listening.
All right. So let's move to the third part. We have to find the probability that one black ball and one red ball in any other. How do we solve this question? Paula, yes. Rosebud,
Sir,
yes. Go
sir,
ahead.
please. You one black ball will intersect with one red ball, or one black ball will intersect with one red ball.
Okay,
So it will be 5/20 times 8/20 plus 5/20 times 8/20.
okay, thank you. Let's listen to another answer. Jessica Maunya.
Sir,
Yes,
sir,
go ahead. Okay,
sir, you
Kum-
call me.
Kuma Jasper, can you give us uh, your solution? Please mute
Okay,
yourself if I have not called you. Go ahead, please.
sir, so one black ball will be 1/20, and it will intersect with one red ball, which is 1/20. So I multiplied it and I got 1/40.
Okay, that's your answer. All right. Um, please, you can mute yourselves. All right, let's look at the suggested solution. After that, you can compare your answers. So yes, like you were saying, if one black ball and one red ball in any other, then we can have the probability of picking or selecting the first black ball and the second being a red ball, or probability of picking the first one being red and the second being black. So we put their respective probabilities into this expression. This will give us 5 on 20 probability that the first ball is black times 8 on 20 probability that the second ball selected is also red, plus probability that the first ball is red is also giving us 8 on 20 times the second ball being black, 5 on 20. Now, you will see that the denominators there are all the same because we are selecting with replacement. So anytime you select and replace with the same number, the total number of that colored balls will be the same, and the total number of balls in the basket or bag will also be the same. Now, if you simplify the expressions there, we have 40 over 400 plus 40 over 400. So these two expressions will now give us 2 over 10. That is the solution to the question there. Jakpaso Philippine, did you get it?
Yes, sir.
Okay. Daniel Ewoy, is your answer the same as mine?
Yes, sir.
All right. Ilupeju, is your answer the same as mine? Dorcas, is your answer the same as mine? 1 over 5. Okay. So copy this and let's move on. Owusu Godwin, have you finished? William Shepherd, have you finished?
Yes.
Yes, sir.
All right.
So I'm done.
All right. The next thing, and that's the final thing we shall be looking at in our probability theory. Selection without replacement. This time around, if you pick from a particular bag or a basket, you don't have any to replace it. You don't have any. So in that case, the number of the colored object you've selected or you've picked will reduce. And this time around, the total number of items will also reduce. Let me take it again. Selection without replacement. So you have nothing to replace what you are going to select. So if you have a certain number of colored objects in a bag, if you pick a particular color, the total number of that color reduces. Again, the total number of balls or items in that basket will also reduce by that same number or by 1. Let's pick an example. That is why you will go to the market and you will see a tomato seller who is having only, how do we call it? A bowl, one bowl of tomato for 2 cedi. You see, they put it in bowls, plastic rubbers. You see only one rubber. It doesn't mean she came with only that. She has nothing to replace it. She has nothing to put in the other bowls. So you'll see only the one on the table. Let's pick an example and see how it is applied. The first example is this. A box contains 18 green balls and 9 black balls. Find the probability of first drawing a black and a green ball without replacement. So in an examination, the question will tell you whether it is the item you've picked is replaced or not replaced. In this case, we are being told that without replacement, which means if you pick a particular colored ball, you are not going to replace it again. We are finding the probability of drawing first a black ball. So in this case, let's see what we have to do. We know the number of black balls equal to 9. The number of green balls equal to 18. So the total number of balls will be 18 plus 9, and that gives you 27. Now, out of the 27, 9 being black, 18 being green, let's see, we are going to select the first black ball. So, probability that first is black and second is green. Probability that first is black and second is green. This is equal to, now probability that the first ball is black will give us the number of black balls over the total number of balls, that is 9 over 27, times the probability that the second ball that you are going to pick is also green will give us 18 over 27. Now this time around, you can see that the total number of balls has now reduced from 27 to 26 because we've picked one ball. So you are left with 26. So out of the 26, you will pick the second ball. But remember, before you pick the second ball, the total number of green balls still remains 18 because you didn't pick any of the green. So you are picking 18 out of the total remaining, which is the 26. And that will be equal to 3 over 13. Clue justice. Do you understand this?
So yes, please.
Okay. Emmanuel Fumado, do you understand this?
Yes, sir.
Okay. Kudo Da Queen, did you follow that? Okay. Akitipel, your hand is up.
Please, can you go back?
All right. Kaka Beauty, your hand is also up.
Sir, sir, please go over, please.
Okay.
My network is bad.
All right. Dansu Peace, your hand is up.
Sir, please go over. I didn't see your screen.
Come again.
Sir, please go over. I didn't see your screen.
Okay. Can you see it now?
Yes.
All right. What we are saying is this. We have two colored balls or two different types of balls. Green balls and then black balls. Out of this, we have number of black balls equal to 9. Number of green balls equal to 18. So you and I will agree that the total number of balls will be 18 plus 9. That is equal to 27. Danso Peace, do you agree?
Yes, sir.
Good. Now, if you have 27 balls, what will be the probability of picking a black ball piece?
Sir, please, 9 over 27.
9
Because
over
black
27.
is 9.
Good. That is excellent. So, Akitipel, what will be the probability of picking a green ball if you've removed one ball out of it? You will be left with 26. So out of the 26, what will be the probability of picking a green ball?
18/20.
18 over 26. And we know that the intersection there means what? Multiplication. So probability of picking a black ball first times the probability of picking a green ball second will be equal to 9 over 27. That's probability of picking a black ball times 18 over 26. That is the probability of picking a green ball. So if you multiply 9 over 27 by 18 over 26, please, I hope you have your calculator with you.
Yes, sir.
Good. Multiply that. Let's see your answer. Akitipel, what is your answer if you use your calculator?
Please is 3/13.
3 over 13. Please confirm that. Let's see.
Sir.
Please confirm the answer.
9
No, don't give me decimals. Give me fraction like this.
times
Come again.
Sir, 0.23. 9
No,
over 80 gets 3 over 30.
3 over 13. That is correct.
30,
Do you understand
yes.
it now?
Yes, sir.
Akitipel, do you understand it now?
Yes, please.
Good. Kaka Beauty, did you get it?
Yes, sir.
Good. So, have you finished copying the solution?
Yes, sir.
All right. Precious, have you finished copying the solution?
Yes, sir.
Good. Evelyn, are you done with the solution?
Yes, sir.
Great. We move to the second example. Example number 2. A bag contains 12 white and 13 blue balls. A bag contains 12 white and 13 blue balls. A ball is selected at random from the bag and is not replaced, meaning we are selecting without replacing it. A second ball is then selected at random. So after picking the first ball, you will now go and pick the second one without replacing the first one you picked. Find the probability that A or I, both balls are white. I, both balls are of the same color. I, the first ball is white and the second ball is blue. Francis Fumadon, do the first one for us. How do we do the first one? Sorry, Francis Emmanuel.
Sir, please, I'm still solving it. Sir, wait.
Okay, be solving it. I'll call you again to give us your answer. Setra Fiasenyo, give us the answer to the first one, or just explain how you will do the first one. Senor, please, we are waiting for you. Asiedu Divine, can you give us your solution to the first one? Okay. Amenu Dina, give us your answer.
Sir, please, I'm still on it.
Okay. Apedo Root, give us your answer.
Sir, please, I'm still solving.
Okay. Senanu Kelvin, give me your answer.
Sir, please, I'm still solving.
Okay. Theophilus, give us your answer.
So the first one he said probability that both balls are white. So we find the probability that the first ball is white and the second ball is white. So it will be probability that the first ball is white is 12 over 25 times the probability that the second ball is white. Because it was choosing without replacement, the number of balls will decrease. So you get 11 over 24.
Okay.
So
That's
probability that both balls are white will be 11 over, is it 50? 50.
okay. Courage, give us your solution.
Sir, I
Yeah.
also had the same thing.
What do you
To
have?
get a probability that both balls are white, you need to find a probability that the first ball have 11 over 50.
Okay. Tell us your steps.
Okay. Uh, you say you should find the probability that both balls are white.
Yeah.
So they told us that they first picked a ball
Yeah.
and they did not replace it, and followed by the selection of the second ball. So you need to find the probability that the first ball picked is white,
Okay.
and that will be 12 on 25,
All right.
multiplied by the probability that the second ball is white.
Yeah.
And since we did not replace the first ball picked, the total number of the balls present will reduce to 24,
Okay.
making the probability that the ball picked second is white is equal to 11 on 24. And with computation, you will get.
Okay. All right. I think that's fine. That's fine. So let's look at the second or the suggested solution. Okay. There is another question there. Solution. So we know number of white balls and then number of blue balls equal to 12 and 13 respectively. The total number of balls, we have 12 plus 13, giving us 25. So out of the 25, we want to select a certain number. We have to find the probability that both balls selected are all white. So probability that the first ball is white and the second ball is also white. So probability that the first ball is white will now give us 12 over 25 times the second ball is also white. Now you will know that the number of white balls will reduce to 11 and the total number of balls will also reduce to 24. So out of the 24, you are going to pick another white ball. So the probability that it is a white ball will be 11 over 24, since we are left with what? 11 balls. So if you simplify this, we have 11 on 50. So this is the solution to the first part of the question. Jabado, Grace, do you understand? Emmanuel, Fumado, do you understand that?
Yes, sir. I understand it.
Okay. Clue Justice, did you get it? Eunice, did you get it?
Yes, sir.
Okay. Miriam, did you get the steps?
Yes, sir.
Okay. Let's move to the second part. Both are of the same color. We want to find the probability that both are of the same color. Kumi Monica, how do you do that?
Sir, we'll find the first part, which is the probability of picking first a white ball intersection, choosing the second time a white ball, plus the probability of first choosing a blue ball and choosing the second one to be a blue ball again.
Okay. All right. That's fine. So, what's your answer?
That 12 over 25.
Okay. Let's look at the suggested solution. Boku Eunice, what is your answer? Now, this is equal to probability of having the first ball being white and the second ball being white, or probability that the first ball is white and the second ball, sorry, the first ball is black or blue and the second ball is also blue. If you put in the values, we have probability that the first ball is white will give us 12 over 25 times the probability that the second ball is also white will be 11 on 24, plus the probability that the first ball is black is 13 over 20, is blue will be 13 over 25. 13 because we've not picked any of the blue balls. And then the probability that the second ball is also blue will be 12. Now it's 12 because we've picked a blue ball. So 13 minus the 1 will give us 12. And the total number of balls will also reduce to 24. So we have 12 over 24. If you solve these expressions, we have the first expression will give us 11 over 50 plus the whole of the second expression, that is the whole of this, will also give you 13 over 50. So if you continue to simplify, your your answer will be 24 over 50. And finally, if you simplify that, you'll get 12 over 24. So this is the probability of selecting balls which are of the same color. Setrafia Senor, do you understand?
Yes, sir.
Senanu, did you get it?
Yes, sir.
All right. So, Tiola, did you get the explanation?
Yes, sir.
All right. Have you finished copying?
Yes.
Okay. Now let's move on. Let's move on to the next question, the third one there. We are finding the probability that the first ball is white and the second ball is blue. So if the first ball is white, we have probability that the first ball is white, and the second ball is also blue, we have probability that the second ball is blue. So this will now give us 12 over 25. 12 because the number of white balls there is 12, so we have 12 over 25. Now the total number of balls will reduce by 1. So the probability of picking the second ball, which is blue, will now give us 13 over 24. And your answer now becomes 13 over 50. Chantal, are you following?
Yes, please.
Okay. Rejoice, Sedinam.
Yes, sir.
How do we solve the last one?
The last one.
Yes.
Probability that the first ball is white and the second ball is blue.
No.
Okay.
No.
Which one?
Come again. The last one is what?
So you solved it.
We still have one question there.
Oh, I saw it three.
The first two will be white and the last two is also blue. So that's the B part of the question.
Oh, I did not see that one.
Oh, okay. Let me just go back so that you can get that part of the question. So, yes, this is the B part of the question. If 4 balls are taken out of the bag, what is the probability that the first 2 are white and the last 2 are blue? That's the last part of the question. So try that. Rosalind, can you give us your answer?
Sir, please, can you show the question again?
I should show the question, eh?
Yes, please.
That's the question. Can you see it?
Yes, sir.
Good. Yes, who is ready with the answer to the B part? All right. Um, Over patient, is your answer ready?
Sir, please, I'm on it.
Okay. Kaka Beauty.
Sir,
Yes.
sir, I'm not yet done.
All right. I'm still waiting. Anyone who is ready should raise
Okay.
their hand.
Two white
You said
and
you say
last
your
two
answer is what?
289 all over 575.
Okay. Now give us the explanation.
Said the question, they said first two white and last two blue.
Yes.
So the probability, like I did it, P is equal, P into bracket, uh, first white intersect with the second blue plus the first blue intersect with the second blue. I continued 12 over 25 times 11 over 24. That's for the white side. And then I came to the blue side and I did 13 over 24 times 12 over 23.
Okay.
So when I finished, I had 11 over 50 plus 13 over 46. And I had 289 all over 575. So that's what I had.
All right. Thank you. Eunice, I saw your hand.
What can I say?
Sir, please, can you hear me?
I can hear you.
Sir, please, I got 39 on 575.
Okay. Can you take us through your steps?
Sir, please, they said first two white balls and then the last two blue balls.
Mhm.
Sir, so first white ball will intersect with the second white ball
Mhm.
in one bracket
Yeah.
plus then the the last two, that is the third blue ball,
Mhm.
it will intersect with the last ball, which is the fourth
Okay.
ball.
Okay.
So if you continue,
Mhm.
you get 39 on 575.
Oh, okay. All right. So let's. Who is also having a different solution? Akaba said them. Give us your solution. Rejoice. Give us your solution to the problem.
Okay, so I had the same thing as Eunice, but not the same step. So I'll see how I did mine.
Okay.
The probability of the first white ball intersecting with the second white ball, intersecting with the first blue ball, then intersecting with the second blue ball.
Okay.
So the first white ball is 12 over 25, and the second white ball is 11 over 24. Since they are all in the same bag, we've removed two balls. So you are going to subtract the 2 from the 25, which will be 23. So the first blue ball is going to be 13 over 23. And then the second blue ball, 12 over 22. And I had 39 over 575.
Okay.
Yes.
All right. That's your answer. Okay, let's look at the suggested solution. So we are to find the probability that the first two are white and the last two will also be blue. Here is it. The first two, so if you have four balls, meaning they are all in the basket. You are picking 4 out of the total number of balls in the bag or basket. So probability that the first is white and the second is white. And you see, you were told, and the last two. So, and the third ball also being blue, and the fourth is also blue. So, with this, we have 12 on 25, which is the first is white, times 11 on 24. The second is white. Now, the number of white balls will be 11, and the total number of balls will be 24. Times the third is blue. If the third is blue, then we have 13 over 23 because we now have 23 balls left. Then the fourth, if you are going to pick the fourth, that will be 12 over 22. So at any point in time, the total number of balls will be reducing by 1. Now, this will be equal to 39 on 575. So that is the suggested solution to the question. Any problem with this? Good. So we are done with our probability. We shall be taking examples to some questions on how to apply probability in our daily lives. Application of probability. Application of probability. We are now going to apply probability to solve some questions. So we have finished with probability. All that you need to know for your exams, we've done everything. And where probability is being applied, some of the people who uses probability, we made mention of a couple of them. Now let's pick some examples and see how we can apply the laws of probability to those problems. The first one, we have event A and B as such that probability of A equal to 1 over 3 and probability of B equal to 1 over 6. Find probability of A union B if events A and B are A, mutually exclusive, B, independent. That's the first question. You try this question for me. I'll call you to give me your answer. Akaba Sadam, give me the answer to the first one.
Sir, please, I'm not done.
Okay. Amenu Dina, the answer to the first one. Akaba Sadam, Is your answer ready? Okay, Apedo Root, tell them.
Sir, please, I had 1/3.
1/3, that's your answer.
Sir, 1/2, 1/2.
1/2 is your answer. Frank Nukunu. Clue Justice.
So please, I had 1/18.
Okay. Kaka Beauty.
Sir,
Yeah.
I had 1/2.
Okay. So let's look at the suggested solution. Probability of A equal to 1/3. Probability of B is also equal to 1/6. So probability of A union B if mutually exclusive. Okay. We want to find that. So probability of A union B, if they are mutually exclusive, will be equal to probability of A plus probability of B minus probability of A intersection B. And we know that if two events are mutually exclusive, it means that probability of A intersection B will be equal to 0. That is what we have here, meaning they have nothing in common. So your addition law becomes probability of A plus probability of B. And that will be equal to 1/3 plus 1/6 minus the 0, and your answer will be 1/2. So those who had the answer 1/2, you are right. This is the solution to the first part. So we are finding the probability of A union B if, that is, A union B are mutually exclusive. So I can cancel this expression here. Maybe it shouldn't be there. So if A and B are mutually exclusive, then we have probability of A intersection B equal to 0. Equal to 0. So now the second one. Probability of A union B if the two events are independent. Now, if the two events are independent, it means they have something in common. So this time, your A intersection B will not be 0. We are going to have probability of A union B will be equal to probability of A plus the probability of B. The probability here didn't come. There is this one, the P here, indicating the probability of B. Okay, so that's the probability of B minus the probability of A intersection B. This will be equal to probability of A, we know is 1/3, plus the probability of B, we know is 1/6, minus probability of A intersection B will be what? Multiplication, since they are independent. So we have 1/3 times 1/6, and that is going to give us 1 over 2, because we know 1 over 3 plus 1 over 6 will give us 1 over 2 minus, then we have 1 over 3 times 1 over 6 will also give us 1 over 18, not 10. It should be 1 over 18. 1 over 18, please. So you check it here. This 0 should be 8. 1 over 18. So that if you solve everything, half minus 1 over 18 will also give you your final answer. Can you check that for us? Danso piece, 1 over 2 minus 1 over 18. What will be your answer? Amanyo Jessica, what will be your answer?
It's
Yes,
4/9.
4 over 9. All right, thank you. Thank you. So that is the solution. We quickly take the last example, then we bring our lesson to a close. Okay, so the second one, we have this. Maybe it will, okay, let's see. Out of the 24 apples in a box, 6 are bad. If 3 apples are taken from the box at random with replacement, find the probability that A, the first 2 are good and the third is bad. B, all the 3 are bad. C, all the 3 are good. That is the question. I want everybody to take this question, try this question, and you will send the solution. I'll be sending the same question through the Google Classroom so that you send your solution as assignment. The previous assignment I gave you, yes, I had a little problem with my machine, so I couldn't mark it. By tomorrow, you'll receive that result. Is that clear to everybody?
Yes, sir.
Okay. So this
Yes.
Yes, sir.
brings us to the end of probability, and our next lesson, will be on uh,
Yay.
vectors and bearing. The next lesson will be vectors and
I don't
bearing.
The answer will be 9 over what?
So I want you to start preparing on vectors and bearing before we meet next